Hello and welcome back to Mikey's Flightdeck. In this video I will show you the build process of the center panel of my MIP panel, including a dual needle flaps gauge. During this project I finally found time to try out a new method that helps me to save areas on the panels from paint. Many panels are fully painted, or the top panels for the engraving, but when it comes to the middle or bottom layer of the panels, then most or many areas have to stay clear from paint to let the backlight coming through. My acrylic comes with a plastic cover that comes loose from time to time, and especially at the edges it tends to come loose from the acrylic, and so this is not the way to let this covering on top of the acrylic plate and remove it after painting. So I removed the covering completely and masked the areas out with tape that shouldn't be painted. But the smaller the area are and the more there are on the panel, the more time consuming it was to place all the masking tape on the panels. And now I thought, could the laser be again a help to me? I started to use the laser to free smaller areas from paint, so I engraved them free. And this can be done where another panel comes on top and no light comes through the edges of this upcoming panel. And now I tried out another method. I'm covering areas that should stay clean roughly with tape, and then I have made a cutting line for my laser that is the outline of the different shapes that should stay clear, and then I'm setting up the laser so that it just cuts through the tape and I can remove the tape around this shape. And this works really well and is definitely faster than engraving bigger parts of the panel free. Before I install the hardware into the bottom plate of the panel, I want to check if the legs of these little LED tactile buttons are long enough to reach through this 3mm acrylic plate here. And as you can see, the legs are too short. They hardly reach the other side of the acrylic. Yeah, but this is way too short to be mounted into the plate and way too short to be soldered then. But I want to install them into this sheet here, and so I think I will countersink some of the holes here from the back side so I get rid of some of the material and have more room to solder and glue them in place. You will need a big momentary on-off-on switch. These two 8-position rotary switches are built in my slightly edited dual rotary encoder holder together with two encoders. Now I started the building of the Autobrake switch. For the Autobrake switch, I came out with this design here. On the 8-position rotary switch here, there I will mount a coupler. On one side it can be mounted to the switch and fixed with a set screw here. And on the other side it has a flat shaft here, so that it can be connected with the shaft of the Autobrake switch here. So this will come on here. The shaft will be inserted into the middle plate of this switch here, which will be mounted in like this. And now you can see here the rotation can reach the needed positions of the switch here until it comes to this stop here. And to get over this stop to the last position, you have to pull the switch, and then you can reach the last position, the max position of the brakes. But to produce a force that you have to pull against, there will be a spring mounted in here, and then this spring will be between some spaces here. Just for demonstration, there is the top plate that will be mounted on here. And through the spring produces a force that wants the shaft to come back to its down position. Yes, and so when you are in the max position and you rotate the switch back here, then the spring will force it down again. Here comes the engraving of the painted, resin-printed button caps. The upper top panel is glued in place with some epoxy. Hello, this is me, the Mikey from the future. Many weeks after the following scenes took place. This gauge went through so many iterations like no other gauge before. And I want to give you some informations before you see the following scenes, because the version you will see now isn't the final result. At this point, I still try to determine the zero position of the stepper motors with some photoresistors, which didn't work at the end, but let's see how this design came out. The mounting plate for the two motors, which will come in here like this on this side and on this side here, needs a little bit of preparation before you install all the components. We will need place for the rotating arms here of the motors, and screws will come in here from the back side as well. And to not collide with these screws, you will have to sink the 4 inside screws from the top side here and the 2 outside screws from the bottom side. Here you can see the needle before and after the engraving. One of the photoresistors had to be raised to avoid a collision of the 2 rotating arms. I'm always looking for techniques to be more efficient when I'm producing my parts, especially when I'm producing more than only 1 or 2 of them. And so I came out with a new technique to produce my Boeing knobs, especially the black lines on these knobs. I created a 3D model where these lines are engraved into the model. After covering them with lacquer, I want to rub in black wax into the grooves. This will be much more precise and faster than masking these areas out with tape. And I found out that the spray paint that I'm using to cover the knobs feels much better as the lacquer from the airbrush pistol, but it doesn't stand as good the solvents that I'm using to rub away the wax. And so it is good to cover it with a coat of clear varnish after the painting, then there shouldn't be any problems. And I finally found a nice connector for my backlighting cables. This is a connector normally used in cars. You can see the panel is fully wired, and I was already starting the configuration for this panel when I noticed some problems in some of the components here. Let's start with these rotary or dual rotary encoder switches here. Especially the bottom knob here is really wobbling, so very loose here. You can see it down there. It is really loose and can wiggle here. But for the wiggling knob, the solution can be a longer leading here of this shaft. You can see when it is just pushed through such a small or thin-walled hole, there is a possibility to wiggle here, but with this extension here, as long as possible, there is not much play left anymore, and I hope this will solve the wiggling problem. Another problem is here in the gauge. Again, it has to do with the wiggling, and especially with this gear here. This is wiggling really much because it is just sticked onto the stepper motor, and I think this wiggling continues here to this shaft here, and this leads me to problems to let this lower needle here run smooth in the hole. So my first thoughts were to extend the shaft here and let it go through the middle plate here, but I became aware that there is still too much wiggling in here when it comes through. And so I came out with this idea here. The extended shaft, the gear is set back here in place, and then a small covering is stick to the top like this, and this goes into a little bit bigger hole, but there is not much play left, and I think this can solve the wiggling problem. And if I can't get rid of the wiggling of this bigger shaft here, I will make a 3D printed middle plate again with an extension here, so that this shaft will run into a leading hole. Now, nearly at the end of the project, it is time to make a step back, because I'm using those optical sensors as a zero switch, and I think those aren't really supported by MobiFlight. I have seen some strange behaviors of the stepper motors that I can't explain, and so I think it's time to try normal switches again. In detail, those micro switches, I will install 2 of them in the bottom plate of the gauge, and because I haven't still found those 2mm screws to fix them, or at least they aren't available in the Home Depot stores, so I will use 2mm brass shafts that I cut to length, and I will glue them into the plate and then set the switches over them and fix them with hot glue. I think this will hold good enough. This will reduce the configuration amount that I will have to use later, and also reduce some wiring work here for the gauge. Though there are also good points in this changement. But of course, the finishing of this panel will take more time now. Now the epoxy glue has dried and the shafts are sitting really tight here, and I will be able to slide the switches over here like this, glue them in place, and then connect the cables, and I think that I'm ready to go. But when I started doing this, I made a big redesign of my gauge. I experimented a little bit with different gears made on my printer, and I was really surprised that the gears came out so nice. I always thought it would be better to make the gears on my laser cutter from plexiglass, but I think the quality of the gears here is comparable, and I think they should be as durable as plexiglass. And then I thought about if it would be possible that I print out the construction here that I have made from the cutout gear and all other pieces here, and print it out in one piece here. And here it is. This worked out really well. The finger here, or this bulk that will push the button here later. There is the other one. And then I started a redesigning of the gauge. First of all, I extended this guide here of this plate and made it longer, so that it will sit flush with the bottom side of this gauge here. And this will prevent this disc here from wiggling, I hope. I also replaced this glued version of the gear and shaft here with a 3D printed one. And to prevent it from sliding up here through the gauge, I extended the foot and made it a little bit bigger here. And then it will be mounted like this the disc on top, which will sit in here, the inner needle, and the foot here. And then this only has to be mounted on the motor. And then we have a moving inner and outer needle here. And I also found out that one of the reasons that this plate was sticked in here is that there was some paint inside of this ring, so make sure there isn't any paint inside here. Yeah, lots of problems solved, I hope, and now assemble it again. And even this redesign didn't bring the results I expected. And so I gave up the hope to build a dual needle gauge for a while and redesigned it to a single needle gauge. The build process you can see here. But finally, after the tips from Sebastian from MobiFlight, I came out with a fully working dual needle and design again. So this took a lot of time, and at the end I could finally install it to the simulator. At the end I pressed some 3D printed bezels for the standby gauges in place. For the lower 4 connections I used countersunk screws for not having a nut on the inside that could eventually damage the monitor. And here it is at its final place. I don't know how often I've said this before. This panel took way much longer than I expected. It cost me weeks to find out how to make this dual needle gauge and make the different designs and the programming and so on. And first of all, a big thanks to Sebastian from MobiFlight. Without him, this panel wouldn't be finished yet. But at the end, it shows that it pays off when you don't give up and try to reach the goals you're aiming for. In this case, a fully working panel, and it looks so beautiful. I will celebrate every time I'm setting the flaps. Again, you will find all the needed files to cut out, engrave and 3D print all the needed parts for this panel as a download in the member section of my website. Some parts of the MIP are still missing. I will have to move on. And if you don't want to miss this upcoming episode, then subscribe to my channel to stay informed about any upcoming new video from me. So I hope we'll see us soon back on the flight deck. Ay.